Hi, Henry Le Chatelier, a scientist who studied the effect of stress on systems at equilibrium. What do we mean by stress and how it affects the system at equilibrium? This is what we're going to talk about in this video. Don't forget to watch the video till the end and ask at the end of video questions. Let's start. Henry Le Chatelier studied the effect of a stress or a change on a system at equilibrium. His findings are known as Le Chatelier principle, which states that if a system is at equilibrium and we apply a change to that system, the system will oppose that change in a way to eliminate it or to minimize the effect of that change. Let me give you an example. Imagine that we have a tube of toothpaste. The toothpaste and the tube itself, they are making an equilibrium. If I squeeze the walls of the toothpaste, now I'm applying a change to that system. I'm increasing the pressure on the walls. So what's going to happen? The toothpaste inside the tube will go outside to decrease the effect of that pressure or that change. There are three different types of stress that we're going to explain in this video. We're going to explain the effect of change in concentrations of products or reactants in a system at equilibrium. We are going to study also the effect of changing the temperature on a system at equilibrium. And finally, we are going to study the effect of changing the pressure on systems at equilibrium. Let me explain what will happen if we change the concentration of one of the reactants or one of the products of a system at equilibrium. Imagine that we have an equilibrium between A and B to give C and D. What if we increase the concentration of A? Then that extra amount of A will react with B. So the amount of B is going to decrease because that amount is going to be consumed by the extra amount of A that we added. So the concentration of B is going to decrease. And since we have more A and B reacted to give products, so the concentration of C and D will increase. So when we add the concentration of one of the reactants at equilibrium, the other reactants will decrease in concentration while the products will increase in concentration. Now, what if we increase the concentration of one of the products? What if I increase the concentration of C? Then D is going to be consumed. So the concentration of D will decrease. And since D and C are reacting to give more A and B, the concentrations of A and B will increase. So if I increase the concentration of one of the products, the other products are going to decrease in concentration while the reactants are going to increase in concentration. Now, the opposite is going to happen if we decrease the concentration of one of the reactants or one of the products. Let me explain. If I decrease the concentration of B, okay, then C and D will try to react in a way to cover that decrease. So C and D will decrease in concentration also, and the concentration of A will increase. Another example. What if we decrease the concentration of D? Then A and B will try to cover that amount which is missing from D, and they will react more, so their concentration is going to decrease, and there will be more concentration of C, or the concentration of C is going to increase. So in case we decrease the concentration of one of the reactants, okay, then the other reactant is going to increase and the concentration of the products are going to decrease. If we decrease the concentration of one of the products, then the other product is going to increase and the concentration of the reactants are going to decrease. To study the effect of changing the temperature on systems at equilibrium, we have to differentiate between two types of chemical reactions: endothermic chemical reactions and exothermic chemical reactions. Endothermic chemical reactions are reactions that need or require energy, while exothermic chemical reactions are chemical reactions that release or produce energy. So in case we have endothermic chemical reaction, the energy is needed, so we consider the energy as one of the reactants. So I'm going to write the energy in this side. Now, if we increase the temperature, as if we are adding more energy, we are increasing one of the reactants. So we are pushing the reaction forward. So the concentration of A will decrease and the concentration of B will decrease because one of the reactants is increased. And the concentration of C will increase and the concentration of D also will increase. So in case we have endothermic chemical reaction and we increase the temperature, as if we are pushing the reaction forward, so the concentrations of the products will increase and the concentration of the reactants will decrease. Now, what if we decrease the temperature? When we decrease the temperature, as if we are removing one of the reactants, so now the products, they will try to recover that amount of reactants which is missing. So if we decrease the temperature, the concentration of the products will decrease also to recover that amount, and the concentration of the reactants will increase. This is what happens if we change the temperature in endothermic chemical reaction. But what if we change the temperature in exothermic chemical reaction, where the temperature or the energy is going to be considered one of the products? In this case, if we increase the temperature, as if we are increasing one of the products and we are pushing the reaction backward. So if we increase the temperature, the concentrations of C and D will decrease and the concentrations of A and B will increase. Now, what if we decrease the temperature? So here we are decreasing one of the products. So the reactants will try to cover that amount of products which is missing. So the reaction will go forward and now the concentration of the reactants will decrease and the concentration of the products will increase. Finally, let's talk about the effect of changing the pressure on systems at equilibrium. You have to keep something in your mind that when you change the pressure, only gases would be affected. Chemical equilibriums and solutions are not going to be affected. Now let me explain the effect of changing the pressure on this chemical equilibrium where the hydrogen and the nitrogen are going to react to produce ammonia. If we change the pressure on this chemical equilibrium, as you can see, we have in the reactant side 3 moles of hydrogen and 2 moles of nitrogen. So we have 4 moles on the reactant side, while if you look at the product side, we have 2 moles. Now, if you increase the pressure, the reactants would feel more pressure than products. So if we increase the pressure, as if we are pushing the reaction forward, we are squeezing the reactants to react together and to give more products. So their concentration is going to decrease, while the concentration of the products will increase. Now, what if we decrease the pressure? If we decrease the pressure, the opposite is going to happen, as if we are pushing the reaction backward, and if we decrease the pressure, the concentration of the ammonia will decrease and the concentration of the nitrogen and hydrogen will increase. So if we change the pressure, only chemical equilibria with different number of moles between reactants and products would be affected. But what if we have the same number of moles between reactants and products, like the chemical equilibrium reaction between water and carbon monoxide to produce hydrogen and carbon dioxide? If you look at this chemical equilibrium, you can see that we have 2 moles of gases in the reactant side and 2 moles of gases in the product side. So here, if we increase the pressure, none of them is going to be affected more than the other. The reactants and the products, they have the same number of moles. So if you increase or decrease the pressure, nothing would happen. So if we change the pressure on equilibrium reactions that have the same number of moles between reactants and products, nothing would happen. And now you are ready to solve the end of video questions. If not, repeat the video again. If you find my videos are useful, subscribe to the channel and hit the bell icon to get notified and watch the new videos. Don't forget to share this video with your friends and write me a comment. Thank you.